Okay. Students, oh, please confirm whether the presentation is visible to you or not. Is it visible? Hello. Just confirm, is the presentation is visible to you, students? Anyone can reply. You can reply whether the presentation is visible or not. Please reply. Otherwise, I have to again
Yes, sir.
mention. Yeah, thank you. So this is assignment number second. In that A part, that is there are three assignments in assignment number 2. 2A assignment 2A is configuration of EIGRP using packet tracer. Assignment 2B is configuration of OSPF routing protocol using packet tracer, and 2C part is configuration of wireless LAN static and DSCP settings, right, using packet tracer. So for 2A assignment, that today we'll see configuration of enhanced internet gateway routing protocol EIGRP using packet tracer. And here we need to study the concept of neighbor list cost matrix in this calculation in this particular EIGRP. So this enhanced interior gateway routing protocol is advanced distance vector routing protocol actually. Now a distance vector routing, that is a DVR protocol, requires that a router information yeah, that the router inform its neighbor of topology changes periodically. That is the concept of the distance vector router, right? Whenever there is a change in topology of a router, it will going to update that particular change to the its neighbor router. That means yes, there is particular network added or particular terminal added to the router. If there is a change or update, a particular router will going to update to the neighboring routers about this updates in distance vector router periodically. So whenever we are discussing about this distance vector routing, actually it's advanced distance vector routing EIGRP, right? This distance vector routing protocol in data networks determines the base route for a data package based on the distance actually, right? Now the distance vector routing protocol measure the distance by the number of routers a packet has to pass, or one router count as one hop. That is the concept in the distance router. As you know that in a routing information protocol in the assignment 1A routing information protocol configuration. So the distance is measured as a number of hop count required to reach from source router to the destination, right? So if the hop count is minimum, that will be treated as the base route, right? So here in enhanced interior gateway routing protocol, this is based on the advanced distance vector routing, and we are going to consider the cost, that cost required to reach to the destination. If the cost is minimum, then that particular distance will be considered, right? So how to go about this, or how to start, that we'll see. So it's a standard protocol. That means initially it was used for the Cisco routers only. Now it's a generalized one, standard protocol for advanced distance vector routing, EIGRP. It's a classless routing protocol. Then includes all features of this internet gateway routing protocols. Then max hop count is 255, and by default the max hop count is 100 in EIG, but maximum you can set a hop count as consider as a 255 in this particular enhanced internet gateway routing protocol. Then administrative distance is 90. So concept of administrative distance that is considered in this particular enhanced internet gateway routing protocol is 90 here in EIGRP. Now whenever suppose we are considering this classless routing protocol, that means it refers to a type of routing where the router uses the default route to forward traffic if no other specific routes are found, right? So it includes subnet mask information in the routing update, and this particular EIGRP support this particular classless routing concept of classless routing. Then whenever you are supposed to consider that administrative distance. This administrative distance is 19 EIGRP. So this administrative distance, or sometimes called as AD, or route preference, administrative distance, or say AD or route preference. It is a number of arbitrary unit assigned to dynamic routes, static routes, and directly connected routes, right? It's an arbitrary unit that is assigned to that particular, maybe static route, dynamic route, right? So that is the administrative distance. So the value is used in routers to rank routes from most preferred to least preferred. Now, how to consider particular route is most preferred and say least preferred. Suppose the administrative distance is low, that means very less. That means low administrative distance value will be treated as the most preferred, right? And if the administrative distance is high, then that considered as the least preferred. That means whenever this particular administrative distance is low, that will be the most preferred route. And if the administrative distance is high, then that is referred to as a least preferred route. Always remember this. Then it will offer you the flexible network design. Then multicast and unicast instead of broadcast addresses addressing is used here. That means whenever source router sends certain information to the second, it will be multicast, and when a reply will come back to the source, it will be unicast to that particular source. It's 100% loop flake classless routing, right? Then easy configuration of wireless area network and the this local area networks, right? So these are certain features of this EIGRP protocol. Then whenever we are seeing that this EIGRP is a flexible network design, that means based on number of routers, it will going to build certain tables. Those will going to see in the consecutive parts, and based on that, the flexible network design can be offered to it. Whenever we are saying this is a loop free classes routing, that means EIGRP is a provides loop free classless routing. That is a feature that allows this EIGRP to switch to a backup path in less than say 50 milliseconds, right? So fast route, fast route means we'll switch to that particular previous route within you can say that 50 milliseconds. So there's no as such problem coming for the switching, right? So we switch to another next hop or loop free alternative, right? So for you can say that such type of facilities provided in EIGRP. Then consider this particular concept when we are supposed to see this particular EIGRP in detail. See router A and router B. These two routers are there, right? Then A and B router wants to communicate with each other, right? Then say here different tables we are going to build in EIGRP for communication purpose, and at the same time to select the best route to reach to the destination. So we are going to build this neighbor table, topology table, and the routing table. Neighbor table, topology table, and the routing table. So whenever that means whenever you are to implement EIGRP, you are supposed to configure those ERP with on routers, right? Participate in the communication. So we are building such tables, neighbor table, topology table, routing table on these routers on A as well as on B, or whatever the routers participate there. We execute the EIGRP commands on these routers, right? And then we'll check neighbor table and their configuration to ensure that EIGRP protocol is working on those routers, right? Now here say first when you say that there is an exchange of hello messages, right? That means there are certain steps in the steps 1, step 2 in this particular EIGRP routing. So what are those steps? Those we are supposed to see here, right? So just see here, two routers are there. This A router maintains this neighbor table, topology table, and routing table, and B also maintains this neighbor table, topology table, routing table, which are built in consecutive steps like step 2, 3, 1, 2, 3, like this. In these tables, this in this those steps, these tables will be built. Now what is step one? The step one is sending hello messages and getting reply and forming neighbor table. That is neighborship table building is the first step. The first step is the neighborship table building. Now here, suppose now A, B, C, D, suppose here two routers are there, right? Consider these two routers. Now how this particular A router know about the B is there, who is his neighbor? So for that, the A router sends the hello message to B, and this particular B router sends some reply. A receives that particular reply and forming its own neighbor table. That means A sends hello message. That means I am a router A who is on the link on the other side, right? Then on the other side, this particular B will send hello, I am a router B, right? I am a router B. Now here this particular A router gets the complete information about the B router. So the A will be its own neighbor. Now same thing happens to this particular, you can say, other part. That is B will again get update about the A, and it will also prepare its neighbor table, right? So here actually this neighbor table replies with the hello, and at the same time it will update this particular B update to A about here is my complete routing information. Whatever the routing information present with the B, that B will update to A, right? So then A will complete its neighbor table. Same procedure happens to the B. That means after this table, then this particular next steps comes into the picture. That means exchange routing information. That is topology table building. Now you are supposed to build the topology. That means exchanging the routing information. So here in this particular first step, A router knows who is his neighbor, B router know who is its neighbor. So that neighbor table is built. Now in the next table, next is nothing but topology table building. That means exchange of routing information. Now sending and receiving updates and acknowledgement from both the sides, right? So here both routers A and B sends updates and receive updated, and finally you can say that receive updates and finally they said acknowledgement to each other. That means this information will build topology. It stores all the base root from each table. Right? Always remember it stores all the base root from each table in the topology table. Now this topology table here you are supposed to remember one thing in the topology table. Suppose uh, that means this particular whenever some information B will send the routing information to A will say acknowledge, that means yes I received the information. Then B will A will send here is my complete routing information to step B, right? Then this particular B will reply acknowledge thanks for the information, right? So here exchange of routing information done in the second step, and you are building the topology table. The topology table will be built in the second step. Now to understand the topology table on, you can say, more detail, just come to this particular point. Now say I will use some shapes to make you understand this. Now suppose I will use paint actually, so that will be better idea. Suppose here router A, right? Suppose one more router, right? Just for your understanding of step A and step B, right? Now suppose I am seeing this is A router, right? A, then this is say for example B router, this is C router. I hope this is visible to you, right? Now here suppose the something, some connection or something like this. So like, so A will send its information, that means hello I am A. B will reply I am B. That means A and B are the neighbors. So A will be its neighbor table, B will be its neighbor table, A will also be its neighbor table, B will also be neighbor table. But this D is not neighbor of A. Remember that. In the second step, routing information exchange will be done. That means you are building the topology. Means what? Suppose from this particular point, just I'm giving the example. Now this is A, B, C, D router. Now uh, B has, say, suppose B has 5 routes, right, to reach to this particular D, right, and this particular C has, say, 3 routes to reach to the particular destination, say D, right. But now A wants to know that how many routes are there from A to D and, say, A to D to reach to the D, right? So B is having 5 routes in this particular way and C is having 3 routes. But whenever this particular routing information will be exchanged between A and C or A and B, then only out of these 5 routes, I'm not drawn all the 5 routes. I'm just saying here, just assume that here actually another 5 routes are there to reach to this using some another routers. Say five routes are there from B to reach to D and 3 routes from C to D. Then in the topology table, how it will going to put, the B will send only the best path to the A. That means only one best path out of this 5 will be sent to A, and C will also send only the one best path to the 3. That means out of 5 only one best path will be stored in A, and out of 3 only one best path will be stored in A's routing information, right? Then whenever suppose there is some another router here, then this particular A will exchange the best route out of these two with that particular router, right? So this information will happen like this. But here point to be noted that only the best route will be exchanged that in the topology, and other topology table will be built. I hope the concept is clear to you now. Then next is nothing but point is nothing but you are supposed to build the routing table, right? So in the routing table, out of what actually happened in the routing table, uh, as I told you that here, see, only in the A's routing table 1 and 2, these are the two, you can say, that entries for the base route to reach to the destination, right? Now out of these two base route in this, the out of these two, which is the, again, base route, that will be considered for the routing purpose. So that will be stored in the routing table of this particular A. So that is the third step of building a routing table, right? Now see, these are the tables I told you. The neighbor table, how it is built, it contains list of directly connected routers, right? And the command that is used, show IP EIGRP neighbor. Second, topology table. Here list of all the base routes learned from each neighbor. Here actually what I want to tell you that list of all base route learned from each table. That means out of 5, say, one route will be exchanged with the A. Then for, say, another router, out of 3, one will be exchanged. So you can, using this, build a topology table for that particular router, and you can check this by show IP EIGRP topology. You will get that. And in the routing table, the base route to the destination will be considered. That means whatever in the topology table entries, out of that, which is the best entry to reach to the destination, that will be considered, and that you can check using show IP route. So these are the tables those you are building. Now here, just again, if you want to check neighbor table, how it will go, say a router R1, R2, R3 and R4, for your understanding how to build a neighbor table again in detail. So here R2 and R3, they are neighbor of this particular R1, but this R1 and R4 are not the neighbors. So this R1 and R2 will exchange the hello messages with each other and builds the neighbor table. Then topology table, here just consider that R1, R2, R3, R4, these four routers are there. R5 is one more router, and there are pieces connected to R5. This is another suppose network, right? Now here each node will get one base route information. That means, for example, R2, I already told you that 5 routes are there for suppose you want to reach from R1 to R5 or to this particular network, and there are 5 routes from the R2 to reach to the R5 network. That means this entire network. There are 3 routes here and there are 2 routes here. But whenever in the topology neighbor, whenever they are updating the information with each other, they only update the base route out of these 5, not all the 5 routes. Always remember that. Out of these 5, one will get exchanged with R1 base route. R3 base route will be exchanged with R1, and R4 base route to this particular network, that only one route will get exchanged with the R1, right? So in this particular fashion, R1 is now having 3 base route with this. Now R1 is having 3 base route with it to reach to this particular R5 network, right? So there are total 10, 10 routes, but out of that, this R1 now gets 3 routes to reach to the base route to reach to the R5. Now, in the routing table, finally in the routing table, we will write the base route out of these 3 base route got in the topology table. So यहाँ पे जो आपको 3 base route में उसमें जो base route है to reach to the destination, that means with minimum cost, that will be treated, right? So here R1 will have only one base route out of this 3 route to exchange with its other neighbors, right? So यहाँ पे जो आपके पास अगर 3 base route हो गए, तो whenever you want to reach R5, you will use that particular base route, and if some another node is there, router is there, and if R1 wants to exchange the information with this road, that means which is the base route to reach R5, out of these 3, only one, this R1 base route will be exchanged with the next router like this. So this process will goes on. That is the concept, right? Now another important points are related to EIGRP. Updates are through multi-class. That means whenever multi-class on 224.0.0.10, right? On this particular IP, the updates are there through multi-class. That means whenever A sends hello, it will be multi-class on this particular 224.0.0.10. Then hello packets are sent every 5 seconds. Always remember that there is a continuous, you can say that you are sending the hello packets after every 5 interval, or periodically hello packets are sent to the router to check its aliveness, or in short, to check or update the neighbors related to is the neighbor is same or change, something like that. And if you are not getting response after say some specific say 14 second, 20 second, I think 14 second is there, then that link will be considered as discard and new neighborship will be established. Conversion rate is faster. That means mapping of this 3 base route to 1 route and then updating the R1 table, that is very fast, right? That convergence rate is very fast here. Support these IP, IPX and AppleTalk protocols. Then it uses the diffuse update algorithm for its implementation. Actually, dual. It uses dual, that is diffuse update algorithm. Now and that the diffuse algorithm is the algorithm used by the Cisco EIGRP routing protocol to ensure that a given route is recalculated globally whenever required. So that's diffuse update algorithm is used accordingly, right? The algorithm is used by this EIGRP here, right? And it is used to recalculate the global, that means the route globally whenever it might cause a routing loop. So for that particular, that algorithm is also used for this particular in the EIGRP, and supports equal cost and unequal cost load balancing on both the on that particular network. Now once the 3-step process followed, then after the updates are sent only when there is a change, right? When you say into all the tables, and then the routers will communicate, send the hello message only if there is updates are there, that will be communicated. Other things will not be communicated. But the hello message are sent periodically, say after 5 seconds, to check that neighbor is alive. If we are not getting any reply for 15 seconds, then it is treated as not alive. Then that particular neighbor link is removed. That is the concept. Now there is again next important concept of EIGRP metric. EIGRP metric. So the EIGRP metric is uses 5 parameters. Actually, there are 5 parameters in it: bandwidth, delay, load, and minimum transmission. I think maximum transmission unit and the reliability, right? And out of this 5, bandwidth and I think delay, these 2 are extremely important, and they are used actually because this load, MTU, they are all variable factors, right? This maximum transmission unit, MTU, reliability, load, they are variables, and they are actually not, we are not going to consider them for the calculation of this EIG metric cost. So bandwidth and delay are considered. The formula with default K values. So K values are nothing but K1 is equal to 1, K2 is 0, K3 is 1, K4 0, and K5 is again 0. When you use this particular metric is equal to K1 into bandwidth plus K2 into bandwidth divided by 256 minus load plus K3 into delay. When you place K2, that is K2 is 0 into that is 0 by something, that will become, there is no meaning of it. So your formula will obviously become metric is equal to K1 multiplied by bandwidth plus K3 multiplied by delay, right? So here ERGP is calculating best route based on the 5 factors, that is bandwidth, delay, load, MTU, and reliability. So here please note only bandwidth and delay will be considered for metric calculation, as load and MTU and reliability are variable, so they are not considered for calculation. So this is automatically calculated by router this EIGRP metric and its cost will be automatically calculated by the router, right? And EIGRP accordingly. So it will going to give you the cost. So least cost is the best. That means whenever you'll get the value over here, so that value is nothing but the cost value. If the cost is less, that will be considered as the best route. If you will get the least cost, that will be the best route. That means the route which is having the least cost is the best route. So when bandwidth is more, then cost is coming less. Always remember that. If your bandwidth is more, then your cost will obviously going to come less. That means faster transmission will going to occur with maximum bandwidth. So that is the concept. So in RIP, the base route is routing having least hop count, but this is not the case with this particular EIGRP. EIGRP में आप cost use करें, least the cost, base the route. When the cost will come less, whenever bandwidth will be highest, your cost will going to come less. So that is the concept. And again, say for example, your default bandwidth on serial link. Now there is a concept of say what sort of bandwidth you are supposed to consider. We'll see one example and I will explain to this. Say for this is your how bandwidth and delay is calculated, that we'll see. So this is serial link. So on serial link, default bandwidth will be 1554, right? And on say other link, if you are changing it sometimes 64 kilobit per second, right? Then delay you are passing into to 20,000 macrosecond. Here 20,000 sorry 2,000 macrosecond. So default bandwidth on serial link is 1544 kilobit per second. That means how many bits you can send at one time is the bandwidth. Then default bandwidth for Ethernet. Now serial we know that 1544. Default bandwidth for Ethernet interface, that is 10 Mbps. For fast Ethernet interface it's 100 Mbps, and for Giga Ethernet interface it's 1000 Mbps. Always remember that. So you can check it in a packet resolution command, like you go to the packet and let's say show interfaces, say serial to oblique 0. So and here important point that you need to notice that you can change the bandwidth. That means if you go say R1 and you go to the config mode and just say bandwidth, suppose R1, and you go to config and then say interface serial to oblique 0 and just say bandwidth 1000. So it will change the bandwidth of the serial link from 1545 to 1000, and again that will have an impact on your cost calculation, right? So we can change the bandwidth if there is a change in bandwidth provided by ISP and the link. Here remember that one thing, suppose bandwidth of a link is suppose 1544 and suppose your internet service provider is providing the bandwidth 512, right? And if you are using the 154, that means it will not going to give the actual calculation whether you have to use the, but you need to use 512, so you need to change the bandwidth in that particular case, right? So how bandwidth and delay is calculated. So EIGRP metric for this all explanation is extremely important at the time of oral examination. Always remember that each and everything will be important. So here says, for example, 7 routers are there, A, B, C, D, then X, Y, Z. Now here on this link, say T1 1554 kbps bandwidth, here 1544, here 64 kbps is there, and delay is say 2000 delay on this link. Here 256 kbps is the bandwidth, 256 kbps is the bandwidth, and delay is 2000 on each link, right? Fine. Now A to D, what is the first route? A, B, C, D. If you want to reach from A to D, route is A, B, C, D. Here for this route, and another route is A, X, Y, Z, and D, that is there. Now on this particular route, least bandwidth, now you are supposed for the bandwidth and delay calculation or cost calculation, you have to consider the least bandwidth on this particular link. Now this out of these 1, 2, and 3 values, 64 kbps is the least bandwidth. So that's 64 kbps you have to consider. And total delay is nothing but addition of all delays on those links. 1, 2, 3, 2000 becomes 6000, right? Now for this particular link, we're going to use this 64 kbs and total delay 6000 for this particular route. Now delay is the sum of all delays, as I told you that. So delay will be calculated in tens of microsecond into 256, right? So it will become that 2000 in microseconds converted to microseconds and into 256. And bandwidth is the lowest bandwidth of the link. So here suppose for this route 64. So bandwidth will be calculated at 10 to the power 8. Actually, this formula is 10 to the power 8 divided by bandwidth in kbps. 1544 into 256 into 256. So that bandwidth you are supposed to use accordingly, right? So that bandwidth is you are supposed to use, and whatever the number that will come, that you have to use as the bandwidth in the calculation, right? For this route, again for this list bandwidth will be 256 here, and delay is 8000 for these 4 links, 8000. So using this also you can find out the delay and bandwidth and place this in the cost, and accordingly find out the cost of this link and cost of this link, which is the minimum cost, that will be the best route, like this. Fine. Now here actually we have to move towards the configuring that particular EIGRP. So router, I hope I am there with you. Now here again important implementation path starts configuring EIGRP. Is it visible? Am I audible there clearly, students? Just confirm once. एक बार मुझे confirm करो कि आपको ये दिख रहा है slide. Student.
Yes sir, visible.
दिख रहा है ना ये जो slide थे आपके पास?
Yes sir.
Configuring EIGRP. Yeah. Now see, now actually how to configure EIGRP on packet tracer. So there are few terms, right? You have to go to that particular router, say router enable, then enter conf, then you will come to this particular privilege mode, and then say router EIGRP. If you remember in the 1A assignment, we are writing router RIP. That means routing information protocol we are implementing. But here, as we have to implement EIGRP, we have to route router EIGRP and this AS number. This AS number is autonomous system number. ASGS number is nothing but the autonomous system number. So it can be any number between 1 to 65535, right? That is given by the system administrator. So any number you can use between 1 to 65535. But always keep in mind that to form the neighborship, this ASNO number must be matched on neighbors router. That means suppose there are 5 routers are in a network design. On each router, whenever you are writing this router EIGRP, suppose on a first router you are using router EIGRP and the ASN number 1. So same ASN number 1 you are supposed to use on all the EIGRP configuration on different routers, right? So that number should be same to form the neighborship, right? So to get a neighborship table completely in this EIGRP, the ASN number must be similar. And if the number is same, then only all those routers are implementing the EIGRP protocol and forming the neighborship, right? So in short, this autonomous system number is a globally unique identifier that defines a group of one or more IP prefixes run by one or more network operators that maintain a single clearly defined routing policy, right? So this group of IP prefixes are known as an autonomous system. So that is the concept of autonomous system. So for such type of autonomous system, EIGRP can be used for the communication purpose with same ASNO number, autonomous system number. Now how to do this? Router config. Once you enter this router command, you will get this particular from config-router hash. Enter there. Now you need to advertise the number of network on those particular router, or you can say that you should enter the number of network that particular router knows. So with network and the network ID. So this is advertising network, or we make routers aware of the network. Suppose 2-3 networks को पता है 192.168.1.0 10.0.0.0. So you can enter accordingly. जो router को उस router को जितने networks पता है वो आपको enter करनी. You need to advertise those networks on that particular router. Next, suppose consider this particular scenario. That means we're going to consider suppose this scenario you are considering for your understanding. Routing using EIGRP, so one router, second router, and third router. Here link is there, switches, and PCs. So this is 1.0 network, 2.0 network, 3.0 networks, and here some say this is 10.0.0.0, and this is another, say for example, uh, 11.0.0.0. Now this R1 network, you are writing this command router EIGRP 100. So here suppose instead of 1 you are using 100 as autonomous system number, so you can use 100, but the same number will be there on router R2 and router R3 here, router R3 100 रहेगा. So to form the neighborship. So router EIGRP 100 on this router one. There this particular router knows these two network, this and this, that is 192.168.1.0 and network 10.0.0. Like this for this router and this router you are supposed to configure EIGRP. Right now to check whether neighborship is established or not, you can use the command, say for example on the router 2, on this router 2 you can use the command say do show IP EIGRP neighbors. So it will going to show you this particular neighbors addresses on which interface that particular neighbor exists. So 10.0.0.1 and 11.0.0.2. So these two interfaces are there, 0.0.1 जो यहाँ पे interface वो आएगा and 192.168.1.1, that means this particular interface IP address will come there. राइट लाइक दिस जो भी आपका मीन्स सॉरी ट्रू के लिए देख रहे थे तो ये ट्रू के लिए आपका ये नेबरशिप है दिस एंड दिस देन on serial interfaces, this neighborship is just on this particular serial interfaces with the routers. Router to routing information हम चेक कर रहे हैं. For that routers के आपके interfaces आ जाएंगे. Then on router if we use show IP route, if you use the IP route, then these actually commands are used to check whether EIGRP working or not. Now this is important when you show IP route, so you will get this information. So here 2 points you need to notice: 192.168.2.0 and 192.168.3.0, right? So these are the two interfaces exist on serial ports. That means this 2.2.2 and .3 with this is the administrative number 90, and this is the cost. Actually cost is calculated using k1 into bandwidth and k2 into plus k2 into delay. So for those two routes, number of routes for a particular say any IP route you are checking, so you are checking the routes through this R2. So these are the cost coming for that particular route, right? Now here it you can say that directly connected serial 10.0, and here O means is learning, sorry D means it's a EIGRP and it's in the learning, right? It's learning from the EIGRP. So that thing is you have specifying 2.0 and 3.0, and this is the administrative number and this is the cost for it. So cost can be changed by changing bandwidth and delay value as we already discussed. If you want to, if this cost you want to change or you want to increase the decrease bandwidth, if you change delay, this cost will going to change. It may happen that some a particular base route may not become base route if you alter this bandwidth and the delay accordingly, right? It may possible, right? So here one for this, but when you face on router one, so you will get 192.168.2.0. That means 168 this 2.0 and 3.0. That means 2.0 will somewhere over here this network, and 3.0 is somewhere this particular interface 3.0, right? Routers के neighbors and their paths are shown in this particular case. Then again to check whether again here when you are checking the neighborship using this number, so this path is updated say after say hold for update 10 then 12 it will going to update itself. Updation time is given over here. Then you can use show IP EIGRP topology to check the content of the topology table. So it will show you this particular output 192.168 say 20.0 and one successors. That means if which is very straightforward this network. So that's why one successor is there for this particular R1. If there is one more route from here to here, it will show two successors, right? Like this. It will change accordingly its output. Then and details are given here, right? Feasibility details and all those things are given. Then you can issue IP protocols on router. How which IP protocol is installed there? So you will find that routing protocol is EIGRP on 100 autonomous system ID. So EIGRP is running on the ARM protocol. It shows that. And then actually, what are the K values you are taking? Those K values are in the metric weights of K values are 1, 0, 1, 0, 5. You can change this particular K values also, right? By default, these values are coming. Then EIGRP maximum hope here maximum hope count on this router 100. You can change it to 255 also. There is a command to change it, right? Then yeah, maximum metric variance is 1. Then again, uh, there are maximum path for routing for networks. It will show routing information, uh, gateway 10.0. That means two networks are there which are involved in neighborship relation formation. So that thing is given. So this is one of the output of that EIGRP. You can also ping from router 1 to any machine. So you can go to router 1 ping 192.168.3.1. It shows successful pinging. You can trace out the route 192.168.3.1. So it will show you some when you go to the 3.1. So first of all, it will pass to 10.0.0.2. Then it will move to the next network 11.0.0.3 and then 192.168.3.1. So this is the sequence it is following. So in this particular fashion, you can implement this particular EIGRP. I hope the explanation is uh, uh, up to the mark for this particular uh, EIGRP. Uh, and the commands are also correct. Now we'll step by step for our practical purpose. I have taken one scenario, and that scenario with using packet tracer, we'll do it. Okay. Packet tracer 5.1 we will use here. Okay, it is open. Now see, I will consider network. I think I already have that network with me, design that networks. I will just open it and show it. But before that, I will discuss the file and the steps I have prepared for you. So these are the steps. Which network I will going to consider. You can take any network, any sort of design, and you can check it out. It's up to you. Now see, this network I have considered for you. Consider following network. Step 1, you have to consider this network. ये आपको ये build करना है network, ठीक है ना? Now here see in this particular network, what thing you have to check is, I hope the network is visible to you. I will make it again big. ठीक है. Configuration of EIGRP. So here see 1, 2, and 3 routers are there. Router 0, router 1, router 2. If you want to change the host name, you can change as R1, R2, R3. It's up to you. I'm not changing. I'm keeping as it is. Serial interfaces are there between these routers. Like here, it's a serial 2 oblique 0, serial 2 oblique 0, and serial 3 oblique 0, and here serial 3 oblique 0, and here's 3 oblique 0. Right. Then here clocks are there on the both side. Here clock is there, and again here clock is there. But on the other hand, it's a DTNO clock. Already you know the concept. This is 10.0 network. This is 20.0.0.0 network. This is 10.0.0.0, and this is 30.0.0.0 between these two out. Then machine another network is the 192.168.1.0. IP address of this PC is 192.168.1.2, and here it's 191.161.1 gateway towards this side. Here 192.168.3.2 is IP address, and gateway is 192.168.3.1. Here PC 192.168.2.2, and here gateway is 192.168.2.1 towards the LAN interface on this router, right? And this is 192.168.2.0 network. Now again here 10.0 here towards this WAN, the IP 10.0.0.1, and here 10.0.0.2. Here 20.0.0.1 towards this side, and here you are having 20.0.0.2. That is serial interface IP here. Then here 30.0.0.1, and this is 30.0.0.2 towards this side. Now you have to use these devices, and you have to make the connection. That means IP address enter करनी है आपको. Then you need to enter the router's fast Ethernet and serial addresses, all those things, connection then. So already I have done that. I will take that particular what do you call design as it is directly. So it will save our time. Then okay, okay, fine. I hope the I hope the design is clear to you, right? देखो मैंने सब इसको किया अब if you click here and if you want to check, go to desktop and IP addresses. I think again I have to enter it. Overwrite हो गया शायद ही. Just let me check here. Okay. Oh, I need to enter it once again. Okay, no problem. So see, its IP address is 192.168.1.2 and gateway is 192.168.1.1. Fine. Then here IP address is 192.168.3.2 and gateway is 192.168.3.1, right, for this machine. Then for this it's say desktop IP configuration, say 192.168.2.2 and gateway is 192.168.2.1. Fine. Okay. Then next say fast ethernet. I'm just checking in this say I'm enable करके देखता हूँ, enable and show IP protocols. Right now EIGRP 100 is there already, right? So EIGRP is install करके रखा हुआ है इसमें protocol, ठीक है? So I think IP यहाँ के गए थे. I hope now we'll check configuration of fast ethernet. So on interface fast 0, it is there, right? Now just check here. I'm just showing you. If I'm moving this, for this ethernet on this LAN interface fast ethernet 0/0, if you check this, its MAC is 1.1, correct? Other things are making the port on. Then serial 2/0 interface, that means this one 10.0.0.1 and on clock is there, and this is 3/0 serial interface, WAN interface. So for this 3/0, yes, this is for 3/0 is 20.0 and 220 clock is set, correct? That means it is there. So now then same thing for this router. You are supposed to ensure. I already enter. I'm just checking with you. It is there 2.1, correct? And it is serial 2/0 पे क्या है होना चाहिए 10.10.0.0.2. It is 10.0.0.2, correct? And this on another 3/0 interface should 30.0.0.2, correct? It's coming, right? Then next here configuration for this router, that means this router. So it is 192.163.1 आना चाहिए fast ethernet पे, means I already entered. I'm just ensuring cross checking, correct, coming. And it is another interface serial 2/0, it is 20.0.0.2, correct? And it is and this is 3/0 interface रहेगा 130.0.0.1, correct? Fine. Now you can interfaces are there. Now, as I told you that you need to enter that particular address commands, like say for example, now already I told you that I check EIGRP is configured here. IP EIGRP is 100 we are configured. We'll check with some another CEI autonomous. We'll say I will check here. I will say I think no IP, no EIGRP 100 था. EIGRP, no EIGRP. There is command actually which will remove this. no EIGRP, no IP EIGRP 100. Oh, exit from it. Think again. I think exit now. We'll check. No EIGRP 100. No IP EIGRP. No IP EIGRP. It's actually conft no, no IP EIGRP. Otherwise we need to configure that particular protocol once again. So okay, no problem, we'll see this. Conft will again code it. Say router, say suppose we are taking 101 EIGRP say 101. Fine, then we are adding say network. What is that network here? Now we need to add these networks 1 2 3. So you can add these networks like we'll add network say 192.168.1.0. Then we'll add network. You can check side by side 10.10.0.0.0. Correct. That means this network I'm adding to router 1. Then this 20.0 20 dot network we are supposed to add. Network 20.0.0. Correct. So we added all the three networks advertised on the router 1. Fine. And now if I say show IP pro no, we have to add then we have to exit and let's click here and I will say config save and save settings. Then I will click on this network and on this particular network say command. This is I think network router 1. So here say exit. Already these commands are there. If you check here मैंने कमांड से आप सब सीरियल वगैरह सेट किए थे. If you can so set. There is no as such problem. डायरेक्ट भी कर सकते हैं, कमांड से भी कर सकते हैं. Now here config you can say router EIGRP I think 101 दिया है ना autonomous and then add a network say 20.0.0.0. Correct. Then we can add a network, sorry, network say 30.0.0.0 and then we'll add a network 192.168. I think 3.0 है वो. Correct. This is yes 3.0. Correct. Then exit and click and we can save it again for our purpose config settings and save. And here suppose router 2, then exit, say again router EIGRP 101, correct? Add the networks or advertise the network on router 2 network, say that means router 012. So this is router 2 here. So that means this router. So we need to add these three networks, advertise these three networks on this router. So network say 10.0.0.0, enter. Then network say network say 30.0.0, and then network say 192.682.0, correct? So exit here, config settings and saves. Fine. Now if you want to check, once you configure that particular network here, EIGRP configuration like this, router EIGRP 100 हमने 101 पे किया है अभी, ठीक है? Now router 123 we are configuring, and now to verify the neighborship we use the commands. Now to verify the neighborship we have to use the command on say any router. Say we are clicking on the router, and we'll say on this router, say for example suppose click, and if I'm saying router say conf t, suppose I'm saying here router show here, sorry, exit, and if I'm saying show you will find here show IP protocols on 101. Actually that is initially configured on that actually, so that is showing on the 100, right? The same process for the 100. Suppose here now router say conf t is conf t say EIGRP 1. Suppose I'm writing this command, do show IP EIGRP neighbors, do show IP EIGRP neighbors. Yes, it is showing the neighbors. Now see, actually neighbors on 100 it is showing, and also neighbors on 10. Now EIGRP 100 and 10. So my 101 पे क्या है? Last time मैंने 100 पे कराया था, तो it was there. I have not clear. You can also clear. I think no IP करके clear कर सकते हो. Now 101 पे see 20 and 30. These are the interfaces here. When you check these routers, this router is 20 and the 30. इसको क्यों नहीं लिया? Because this is not on the I can say ending toward the router. It take the neighbors which ends towards the router. So this is 30.0.1 and 20.0.0.2. These two it's coming. So neighbor table you can verify like this, right? In this particular fashion, you can verify the neighbors. That means towards the left side. That means 30.0.0.2. This is the neighbor on serial interface 3/0. It is showing, and 0.1 that means this IP for this router. So ये router और ये router इसके neighbor है. It is showing here on 101. अगर मैं 100 पे करता तो ये 10 नहीं आता, सिर्फ 100 का ही आ जाता, राइट? दिस इज फॉर योर अंडरस्टैंडिंग. ये आपका आउटपुट रहेगा यहाँ पे, ठीक है ना? देन this neighbor table for every router you can check this, and that will be considered as one of the output. Then you can check another output using say clicking on the router and say if you are writing the command show IP route on any router, right? So it will going to show you the route. Now here, if I'm clicking here, exit, show IP ROU. So yes, show IP route. It will show you the route, and this is what these are the administrative distances, and this is the cost. This is the cost. Now here only few routers are there, and direct links we are considering. When number of routers you are increasing, and bandwidth will be different. Here bandwidth is same. That's why the cost coming same. But if the bandwidth you will change, these values will going to change. Always remember this is again an important output that you are getting, right? On router 2. So this 192.168.1.0, this network is there, and 2.0, that means this network is there from this router to these two networks are there, and their cost is coming to reach to those two networks. It's coming over here, right? So that you can also check or cross verify. And D means here EIGRP protocol. It's running from the EIGRP protocol. This D, okay? These two networks and path for it is showing like this. So in this sort of fashion also you can consider this. Then uh, if you want to actually print this particular output, you can print using print scan. मीन्स आपके फाइल के लिए आपको अगर जरूरी है तो ये आउटपुट आप ऐसे भी लगा सकते हो यहाँ पे. I will just paste it so that you can directly take it as your output, right? Previous मैंने आपको बताया था neighborship का. That neighborship output also you can check. Now next you can check the next command, that is now here 90 means already at to administrative distance. ये फाइल में मैंने पूरा दिया है, which is helpful for your preparation के लिए oral के. Now next command you can check the topology table, show IP EIGRP topology. Now when you click here and click here, okay, I'll say any router. I will clicking on the router one, show IP EIGRP topology. Show IP EIGRP topology. See this topology is coming for you. So like this. So here you will get this output. Number of successors. Now here you will find a two successor on 30.0.3. Right here 30.0.0.2 successor will now here from C. Now here I think click on router 1 ना, ये router 1 के लिए router 01 के लिए, but for the router 2 सेम आपको करके दिखाता हूँ. मीन्स आउटपुट भी आपका सेम रहेगा. I click on router 1 and I'm going here and say it's enable and show IP EIGRP say topology. It will going to show you, and on 10.0.0.2 you will find the two successors here, right here again 30.0.0.3 two success. It's actually coming topology for 100. Previously we have installed it, but there are two successors here. Actually if you see here two successors for it on 30.0.0.8. See 30.0.0. You'll find two successor, right? So the same output you are getting. This is 30.0.0.2. Two successors are there in this particular routers, right? For this net, this and these two for this particular network will be treated as the successor of this particular configure table. That is topology table. अगर ये यहाँ से लिंक हटा दे सिंगल रहता तो एक ही सभी जगह वन सक्सेसर रहा था, बट यहाँ पे more than one router, so successor number of successor will be increased. So you can have print screen of this and can use this as output for your that आउटपुट करके भी आपको यूज कर सकते हो मीन्स ये कमांड क्या आएगा आपको सो दिस इज फॉर giving the next command of topology table for every router you can check and cost metric भी हमने देख लिया then next is nothing but you can use the IP protocol which gives EIGRP information show IP protocols मैंने करके दिखाया it is giving you the information about K1 K2 K3 like this right that means when you say show IP protocols on this particular router one suppose say for example if I am writing show IP protocols so it will show you the protocols routing for networks that means k1 k3 values it's showing you default values all those things already we are seen na so ये आप करके देख सकते हो this will be treated as your one output you can print it this output for gateways distance last update then routing for which networking coming from this 1.0 10.0 and 20.0 is there under consideration hope count वगैरह सब आपको आ जाएगा यहाँ पे right यहाँ पे then you can use that as also your output right I will paste it then next you can check the pinging actually right now here uh, you can ping routers 0 to PC or some PC like 2.0 right now if I click on this particular router and if I ping say ping say 192.168.2.2 PC that means this PC if you ping this PC to sending so it's success it should send yes success rate is right that means you are in position to ping this particular PC that means your router is working perfectly EIGRP configured perfectly right so I'm pasting the output for you and its explanation then in this particular fashion you can work you can also trace the destination right so in this particular fashion the route will be also traced right ट्रेस कर सकते हो आप रूट देखो कौन कौन सा पाथ फॉलो किया रूट ने सो मैं आपको पूछना था दिस राउटर से इस पीसी को so it's following the path 10.0.2 that means first of all is going from here to here and then from here to this machine so this is the best path for it so it's the best example of or you can say outcome that we are getting here so absolutely running perfectly I hope you understand what I'm telling you fine okay that's all from EIGRP now you can take the set design and do it I hope you understand it completely right